So good day everyone, I am Vale Sayneil Junio and I am one of the reporters of Group 2, and now we are going to discuss the implementation of classification on Weka and R language. So our objectives is to demonstrate the use of the decision tree, to apply the decision tree on a sample dataset, to implement a decision tree process using Weka and R, and to evaluate the performance of the decision tree model. So what is Weka? Weka is a graphical tool for data mining and machine learning. Provides easy to use interface for applying algorithms, and also best for beginners and for quickly testing datasets. So our programming language is a programming language focused on statistics and data analysis. Offers many packages like Caret or E1071 Random Forest for machine learning. And also it is best for flexibility and advanced custom analysis. So building a decision tree classifier in Weka. So when Weka decision tree is applied to an unknown sample, the decision tree classifies the sample into different classes such as class A, B, and C. The dimensions of an unknown sample of flower will be matched with the rules generated by the decision tree, as you can see in the figure 6.2. So Weka operates its decision tree with the J4.8 or J40 decision tree learner, which is based on Ruskin's landmark decision tree program called C4.5. So Weka operates this algorithm in Java, and the current version of this algorithm is 4.8, which is why Weka named its decision tree learner as the J48. So the iris dataset is available in the data folder of Weka for experimentation. We can avail this dataset by following this path. So then the step-by-step procedure to apply the decision tree classifier is as follows. So step to take when applying the decision tree classifier on the iris dataset in Weka. So start Weka Explorer and go to the Preprocess tab. And under the under Open File tab, select the data source. As you can see in figure 6.4. So move from the Preprocess tab to Classify tab to select the Weka J48 algorithm. Then click on Choose. Then follow the path. Weka classifier trees and then J48. So after selecting J48, click Close to return the Classify tab, as you can see in figure 6.5. So, as you can see in figure 6.6, after loading the J40 decision tree, left click on the J48 to open up the Weka generic object editor. So for our first try to build a decision tree, we will accept all of the defaults here, except that we will change save instance data to true. This will allow us to find out how each iris sample is classified after building the decision tree. By clicking more, you can find further information on the items. And then select, as you can see in figure 6.7, select percentage split from test options and keep default value 66%. It means 66% records. 2/3 of records from whole iris set containing 150 records will be used for training purpose, and remaining records in the dataset will be used for testing purpose. Since the iris set has a total of 150 records, 99 records will be used for training the decision tree model, while the remaining 51 records will be used to test the decision tree. So in order to choose a random 99 records for training the system, it is important to unselect preserve order for percent split. Otherwise, the system will consider first 99 records for training and last 51 records for testing. So in figure 6.9, note that 1/3 of the value samples were Cardoza and 1/3 versicolor and virginica. So moreover, we also specify that Weka is to use 2/3 of the samples to train the classifier, and 1/3 to test the classifier after training is completed. But when Weka splits the original dataset into training and test datasets, we need to have a mixture of species and training set and also in the test set. So now we are ready to run J40 Learner. So click Start on the Classify tab, and Classifier output box shows the results of classification. The portion of the classifier output box seen here verifies that we have analyzed the correct dataset. So, in figure 6.11 edition 3 curve 66, we have a total of 15 Aries Tosa and 19 Aries versicolor, and as you can see, there has a confusion matrix, which is it has a B of 2 and C is equals to 15 in Virginica. So to see the tree, so in figure 6.12, to see the tree, right click on the highlighted result, list entry for the tree we just built, and then click visualize tree. So then after that we can see this decision tree for the iris set. And this decision tree will discussed by one of my colleagues.
Understanding the confusion matrix, there are a total of 51 instances for which we have tested using DWDM. This confusion matrix tells us that DWDM properly classified 15 Setosa, 19 versicolor, and 15 Virginica. However, it classified incorrectly 12 Virginica as versicolor, and it is shown in confusion matrix figure 114. So, understanding the decision tree, starting at the top of the tree, it says that if petal width is less than or equal to 0.6 cm, then the iris species is Setosa. You can see it in figure 6.15. So next is we see that if petal width is greater than to 0.6 cm and also greater than to 1.7 cm, then the iris is Virginica. You can see it in figure 6.16. Now, if petal width is greater than to 0.6 cm and petal width is less than or equal to 1.7 cm, we check petal length. If petal length is less than or equal to 4.9 cm, the iris is versicolor. Weka also reading decision tree rules, Weka also produces the decision tree structure in terms of rules. Scroll through the classifier output box in Classify tab to find the rules that govern the tree. So it is shown in figure 6.18. So next is, suppose we have an unknown iris with petal width 1.6 cm and petal length of 5.0 cm, where petal width is greater than to 0.6 cm and petal width is less than or equal to 1.7 cm. Also, the petal length is greater than to 4.9 cm and the petal width is greater than to 1.5 cm. So the iris is versicolor according to the rules. So we see that the tree has 5 leaves and that the total size of the tree is 9 elements. So you can see the 9 elements in the tree view, the size of the leaves, and kung sa siya nga ang yang iris mo siya, iris setosa or iris versicolor, ang yang petal width. Using rules for prediction. The rules shown in figure 6.18 can be coded to any programming language such as Java, C++, C#, Python, and others, and can be used to predict the class of unknown samples. A GUI can be built consisting of text boxes for receiving values of input attributes on the bottom. Namely, predict can be created such that clicking on it will help in displaying the output after applying decision tree rules. input attributes. Thus, we will be able to build applications such as sentiment analysis, financial analysis, agriculture, placement prediction of the students, and match prediction, and such from the rules built with the decision tree classifier. Introduction to naive Bayes. Naive Bayes is a machine learning classification algorithm that predicts the category of a data point using probability. It assumes that all features are independent of each other. So applying naive Bayes. To apply naive Bayes on any given dataset, the following steps need to be taken. So first is start Weka Explorer and go to the preprocess tab. And next is select the open file tab and select the wither.nominal.rf. So ipakita nila sa figure 6.21 yung pag-select sa wither.nominal.rf na file. Now next is select the classify tab and choose naive Bayes classifier. Then click on more options button and set options and classifier evaluation options. Select the string set option and click start button. Next is after processing. The output will appear where it shows that the correctly classified instances are 13 and incorrect instance is 1. And the overall result is 92.8571%. The incorrect instance is shown in the above figure as a plus symbol in the error column and is the 6th instance. This result also shows that the naive Bayes classifier of Weka has automatically applied a Laplace estimator as shown in modified count. So next is creating the testing dataset. Test the classifier on unknown instances. You have to create the test data. In this section, a process has been illustrated to create a test dataset from an existing dataset. In order to create test instances, follow the following steps. So first, click on Tool option in menu tab and select RF Viewer. Nakikita siya dito sa figure 6.25. Saan na pag-select ang RF Viewer. And next step is click on File, then Open, then select the file wither.nominal.rf. The next step is select all the records in RF Viewer except one record because we wish to keep that as the end testing record instance. In case you want to have end records as testing dataset, then select all the records except first end records. And the next step is click on Edit, then i-delete nimo itong instances na delete nimo gamit ito. Next step is now change the values of one record and set it according to the values that we want to have for the existing record by using the drop down option for setting the value, the attributes. So kita din sa on siya pag bukat ang step 5 sa figure 6.28. So the next step is after changing the values of rows, save the file as test.rf. So next step is now move to preprocess tab and click on open file option and select the wither.nominal.rf file. So pagpagin natin sa figure 6.31, so ano pag-select up ay ang file na wither.nominal.rf. So the next step is select classify tab and choose naive Bayes classifier. And that step is click on start button to build the classifier. And kita nyo sa 6.32 ang classifier output. The next is now select the supply test set option and click on the set button, then open file, select test.rf file. Once the test file has been selected, make sure the data is identified sa name relation, number of attribute, and instances. So this is the result. Yung result atong sa imong gibuhat na testing dataset. So click on the Start button to apply the classifier on the test instances. In this case, the classifier has selected the unknown instance as play yes. So I'm creating testing dataset. Now let us apply the GPT classifier on this test dataset to verify whether it shows the same prediction or not by performing the following steps. So the first step is change the classifier to G48 by using the following steps. Click on choose, then Weka the classifier, trees, and G48. And select the use training set option and click on start button to build the G48. So pagka-click mo sa start, muna ang classifier output ipakita sa 6.35. Next step is now select the supply test set option and select the test dataset as test R. Then click on the start button to apply G48 on the test dataset. You can verify that G48 has also predicted the naive base classifier, predicted the value of playing as yes, which is the same as in the naive base classifier. However, G48 is surer about its prediction as compared to naive base as it predicted with probability of 1.0, while naive base predicted the same probability of 0.824. You can find these values in the output. This is the result. Predicting the value of an unknown sample as play yes by the G48.
So thank you for that. So in the training and testing of the dataset, supposedly we trained the whole dataset to implement the decision tree. And in this section, suppose we want to train the decision tree on approximately 2/3 of the entire sample, and to test the built decision tree on the remaining samples as well. So for example, in this case, we have 150 total samples. So if we want to get the 2/3, we will train the 99 instances, which is the 2/3, and then the remaining 51 is to be tested. And in order to achieve that, we will use the following command. We must first open the package party and then write the indexes sample as 150 and 99. 150 is the total sample and 99 is the 2/3 instances of the iris dataset. And in the iris_train, iris indexes is the command we will use for training the instances, and the iris_test is the command we will use for testing the instances. And then we will set the target species, sepal.length plus sepal.width plus petal.length and petal.width. Then we use the CDT, C3 target iris train, which is the 99 samples or the 2/3 of the 150 for the training of the decision tree. And then we will write the table, predict CDT new data equals iris_test, iris_test $species is the command we use for testing the dataset. So this is how it would look like. If we will see here, we use the exact command. The only thing is that this is 100 instead of a 99, but it's still fine. So in the figure 6.40, we can see that there's a 14 setosa, 19 versicolor, and 17 virginica. However, one virginica, on the other hand, is mislabeled as versicolor. And in order to get the summary of the result, you will use the following command: summary iris test, the testing sample. So the function of the summary is to show this result of the dataset passed as argument. So from the figure 6.40, as I previously shown, is that the summary about the testing dataset, and it shows that the testing dataset consists of 14 setosa, 19 versicolor, and 17 virginica. And and when tested, it observed that the decision tree properly classified 14 setosa, 19 versicolor, and 16 virginica. However, it misclassified 1 virginica as versicolor. Now we'll use the naive Bayes operation in R. So naive Bayes in R can be implemented using different package. However, in this section, we are using the E1071 package to implement the naive Bayes function on the weather dataset. So the E1071 package contains naive Bayes functions, which allows the numeric and factor variables to be used in the naive Bayes model. If the package E1071 is not installed, then you will first install the package by using the command install.packages, open close parentheses, and then there's a quotation mark, and inside that quotation marks we have the E1071. This is the command for to install the package. So after installation, you will load the package using the library command as follows. Here, library E1071 to load the package E1071. Then, after that, the weather dataset may be employed to illustrate how the naive Bayes classification can be performed in R. Then, after loading, we will convert the dataset into a data frame. Using this command, we will load the package first, the library E1071, then the data read.csv. So in this section, this is the file path of the weather.csv. So if you are to use this command, you must know the actual file path, otherwise this command won't work. Then weather_df as.data.frame data. This is the conversion of the dataset into a data frame. So after the following commands, this display of dataset is shown in the 6.42. So weather_df is the command we'll use to display the instances of the weather dataset. As we can see here, there are 3 outlook: overcast, rainy, and sunny. 3 temperature: hot, cold, and mild. There's 2 humidity: high and normal. Windy is false and true, and play is yes and no. So after applying the naive Bayes function on the weather dataset, the result obtained are shown here in the figure 6.43 by using this command: naive_Bayes_model equals naive Bayes. The play in this part is this section. This usually appears, this one appears at the last, like the very right of the CSV file. So when you write this command, you must look at the rightmost section of the CSV file. Then you will call again the naive_Bayes_model in order to call this. So after applying the naive Bayes, we can create a confusion matrix which would help us in summarizing the result of testing the algorithm for further inspection using these following commands. We have nb_predictions equals predict naive_Bayes_model and add the weather df. Then we'll write the table nb_predictions, weather_df, $play, and the DNN equals C, prediction, and actual. So this 6.44, the figure, is the confusion matrix. So as you can see here, it may be a bit confusing, but I will explain it to you. So this confusion matrix is very compact, it's shorthand, so it lacks a label. But in here, I will explain it. So basically, what we see here, this is a false a true negative. This is a true negative. So basically, our model predicted it as 0, and the actual is 0. However, at the same time here in the number 9, this is a true positive, which means our model predicted it as 1 and the actual is 1. The 0, on the other hand, is a false positive. As we see here, basically the model predicted it as a positive, but in reality the actual is negative, which is if we predicted it as 1, then its actual is 0. The yes one here, this is a false negative, which basically our model predicted it as 1 and then the actual is 0. So this is the confusion matrix. So basically what happens is that our model predicted 4 no's, and it is also true. We also predicted 9 yeses, which is also true. But however, we predicted 1 yes when it is actually a no. So our model predicted it almost perfect, but it just have one mistake. Thank you for listening.